final concentration divided by my original, right? So if I finally ended up with 0.75, I originally started with 1, right? So then like this says 75%. This is the ratio you plug in the 75% here. So you just plug in, you can plug in 0.75 here. Does that make sense? So I don't know how he'll give you it, but he could be like, the ratio of the initial to the final to the initial was 0.75 or 75%. So that if he gave you that, you would have to do it. Does that make sense? So some people just write this down, and memorize it, but it's up to you. You can derive it if you remember it. I didn't know it. I actually had to figure it out on the test, but like, you figure it out as you go on. Does that make sense? Any questions? Okay. Is this a good pace? Yeah? Okay. So we have like an hour 10 still. So, okay, so then let's do a problem. This next problem is like put a big star, because like this is gonna pop up. Like I would put $20 to $50 that this will show up on your quiz, just because it's such a common problem. It's a really important problem to know. Okay, so can I erase this? So. So I'm going to say, the way it's going to work is I'm going to say trial, and then I realize I probably can't write too much, but let's figure it out. So 100. Have you guys seen a problem like this before?
Yeah.
Yes, no. Probably depends how far you are in kinetics. I'll give you guys a couple minutes to write that down. This is like probably one of the most common, what's it called? Common kinetics problems you'll get. It'll show up on your like midterm. It'll show up on your quiz. It's like super common. So I would definitely know this one. Okay. So basically, what this is. It's a chart of an experiment that you conducted or a scientist conducted or whatever, right? And so basically you did multiple trials, right? You ran trials and you did all this, right? You like put in, this is initial concentration of A, B, C, right? So the amount that you put these reactants into a reaction, into a vessel, right? And then start one trial you did 10, 100, 700, and then you found out that the rate was that, right? And then you tried this, and then the rate was that. Does that make sense? So you ran multiple trials, right? Now you have to be able to come up with a couple of things using these multiple trials. Does That make sense? So before I dive into that, let me talk about the rate law. So remember how I talked about the rate law? The general skeleton of a rate law is rate equals K. Like that's like you always start with that. So if I tell you write the rate law, you should start it with that. Now what's gonna be next is like concentration of A, B, and C, but they're gonna be raised to a certain power, like X, Y, and Z. So depending on the order, right? X, Y, and Z are the orders of the reactions, and so A to whatever order A is to, B to whatever order B is to, C to whatever order C is to, right? That's a rate law, right? No numbers, it's just an expression, just like the K constant, right? Products or reactants, same idea. Okay, now, using this data, you have to follow trends to be able to tell, like, is this first, is this second, is this third, right? So I'm gonna walk you through how I would do it. So I'm like, okay, I'm gonna start with A all the time, right? So when I start with A, the secret is you wanna pick, you wanna see how A changes the rate, okay? So you wanna keep these two constant while you're watching A change and how that affects the rate. Because if two things are changing, you can't really tell which one's doing what, right? But if like one thing is changing, then you can tell, like, for example, if it's a first order reaction and I double the concentrations, I should double the rate, right? It's like that kind of trend with this, okay? So I look for A, so I want to find A, I want to find compare two trials where B and C are constant, right? So I look, I'm like, okay, these two B are constant, but then C is not constant. And then I'm like, okay, these two, B is constant, but C is again not constant, right? So I'm gonna move on. Like I can't do A, right? Does that make sense? Well, I can't at this moment. You're gonna see in a second, okay? Then, because this is how I tackled it when I was doing the quiz, right? So I'm like, okay, I want to compare B, so I need to find two columns where B is constant. These two, B is constant, but C is not constant. It's 300 and 200. Or sorry, A is constant, 220, but these two aren't the same. Does that make sense? I want to see how B doubles and how that affects the rate, but I can't because this C is not constant, right? So then I try B. This is 100, this is 100, but then this is not constant. Basically, any combination, I realize that C can't be constant, right? So I'm gonna like jump to C. I'm like, okay, I'm gonna figure that out because that's been causing me a lot of problems, and now hopefully jump back, right? So let's look at C. So if we're gonna look at C, we need to pick two columns, two trials where it's the same concentration for A and B. So A 10, oops. So this is 10 to 10, right? It's fine. So it goes from 10 to 10, right? This one goes from 100 to 100. It stays the same, right? So we can monitor this, right? So we're like, okay, we can keep that constant. So comparing trial 1 and 4, C goes from 700 to 400. So that's not really a half or like doubled. It's like a weird number, right? But look, I go from 700 to 400. How does that affect the rate? It stays the same, right? So if I change the concentration but the rate stays the same, what order is that? Zero order. That makes sense? So that sometimes it'll throw a zero order. Basically, now that we found out this is zero order, we can kind of ignore this whole column. Okay? So a lot of people, I usually just start off and be like, oh, let's find the concentration of C. Like, oh, why don't you do A and B? That's my thought process when I'm taking the quiz. Okay? So, and then a lot of times, like, you can't just be like, C is for zero order, right? You can't just write that down because, like, if you just say zero order, like, they're gonna think you're cheating and you like look on someone else and wrote down zero order. So like write down like a little bit of your thought process, right? So what I would write down on my quiz is like trial 1 versus 4, right? And then I'll say concentration doubles, and maybe write like, or sorry, not concentration. So write like 700 molarity to 400 molarity. Rate goes from 2 to 2 molarity per second. Rate doesn't change. Zero order. Like maybe like scribble down your like thought process. right? So now we can ignore column C because it's zero order. We know it doesn't affect it no matter what. Because this does not affect the rate at all, so we could just ignore this whole column. So now let's look at how A changes the rate, right? So if we're going to see how A changes the rate, let's look at column B and keep that constant. So I'm going to pick 1 and 2, for example. These two, the rate, B stays the same, but A changes, and I can see what that happens to the rate. I could have also technically picked 2 and 4, because these two stay the same, but these two changed. Everybody see that? So as long as you keep one the same, it should be fine. So I'm going to just pick these two. So A looks like it doubles, right? And what does that do to the rate? It doubles, right? So what order is that? First order, right? Doubles concentration, doubles the rate, right? So I'm gonna write like over here, I'm just gonna write everything. So again, on your test you should scribble this down, right? But like I'm just not gonna like do it for every single one, but you guys should do it. So but what I'm gonna write the order, and then this is A, B, C. For A it was 1, for B or for C it was 0, right? Now for B, we're gonna keep A constant, so I'm gonna pick these two. I could also pick these two technically. Actually no, I couldn't pick these two, right? Because it's 100 to 100, right? So B would be constant, A would be constant. I'm gonna pick trial 2 and 3 because A stays the same, but B changes, right? So B looks like it doubles, right? What does that do to the rate? 4 to 16 quadruples, right? So what order is that? If I double it, but it quadruples the rate. Second order, right? So then that's going to be second order. Any questions on how I did all that? Make sense? Hopefully. Now, what's my overall order? Everybody know? 3. Just add them now. So this is like the order with respect, the wording will be like, this is the order with respect to A, order with respect to B. And it'll say, what's the overall order? 3. Okay, how do you change the rate law? Well, rate law is going to be rate equals K, and then whatever orders you got, you raise it to that power. So A to the first, B to the second, C to the 0, right? But I could clean this up a little bit. I could just write A, not A to the first, and then C, something to the 0 power is what? 1, so I could just get rid of C and find the rate law. So it's A concentration A times concentration B squared, and that's the rate law. That make sense? Okay. Now let's talk about one thing. He might say like molecularity. I don't know if you guys seen that ever. Molecularity is just like what's like how many atoms are involved on behalf of that one thing. So what's the molecularity with respect to A? It would be there's one thing involved. Look at the order. If the order is 1, there's one thing involved. The molecularity is unimolecular. Does that make sense? Like 1 molecular. Order for B is 2, so that's bimolecular. If I don't know if he'll ask you this, but if he asks you like what's the overall molecularity, it would be trimolecular, right? Because there's 3 things involved. 0, you don't. There's no molecularity for 0 because it's not even involved, right? So this would be unimolecular. This is bimolecular. Overall, it will be trimolecular. So really pay attention to if it says with respect to A or like overall or that stuff, right? Okay. So what's next? So then he'll ask you to find the rate constant, right? So maybe he'll ask you find K, right? Well, if he asks you to find K and we already found the rate law, right? Then you could just plug in values using this data that we have, right? So again, you can pick any trial, and no matter what trial you pick, it should come up with the same K, okay? So I'm just gonna do trial 1. You could have done 2, 3, 4.